Hi everyone, this is Sir O once again, your teacher in this session. So today we are going to illustrate quadratic inequalities. But before that, we will try to recall first our knowledge, especially on inequality symbols. So if we encounter this kind of symbol, meaning to say this is what we call as greater than. Take for example, 55 is greater than 45. So this is read as 55 is greater than 45. So if you notice, the left side is of greater value. Another one, it is say 27 is greater than 12. So if you notice, 27 is of greater value than 12. So this is read as 27 is greater than 12. Another symbol is this one. This is what we call as less than. So take for example, 35 is less than 50. So this is read as 35 is less than 50. So if you notice in this symbol less than, the greater value is at the right side, so which is 50. So another example, say 27 is less than 38. So this is read as 27 is less than 38. So 38 is of greater value than 27. Another symbol that you will encounter also is these symbols. This is read as greater than or equal to, and this is also read as less than or equal to. So with your knowledge on inequality symbols, we have question here to answer. We are asked to identify which of the following are not quadratic equations. So these are the expressions or equations or inequalities. So which of the following here are not quadratic equation? So think, I'll give you 5 seconds. Alright, so if you choose this equations rather or inequalities rather, so these are actually not quadratic equation because this is what we call as quadratic inequalities. For us to understand more on what is quadratic inequalities, let us recall first our quadratic equations. In the standard form, we have ax squared plus bx plus c is equal to 0. Now, quadratic inequality actually, if we are going to replace that equality symbol by greater than, this is now quadratic inequality. So just like if we replace it with less than, greater than or equal to, or less than or equal to are actually quadratic inequalities. So again, we just replace actually the equation, the quadratic equation, the equality symbol by inequality symbol, but the same thing, the polynomial should be in degree 2. So by definition of quadratic inequality, it states that is an inequality that contains a polynomial of degree 2 and can be written in any of the following. Now, if you notice, guys, the polynomial has a degree 2. The highest degree should still be 2, and we use the inequality symbol for our quadratic inequality, where a, b, and c are still real numbers, and a, this one, should not be equal to 0. So the following actually are example of quadratic inequalities. So there are 2 conditions that you need to check for you to consider that these are quadratic inequalities. First is look at if the polynomial has the highest degree of 2. So in this example number 1, the highest degree is 2, so we are correct, and uses a greater than or an inequality symbol. So therefore, this number 1 example is actually a quadratic inequalities. The second one is also quadratic inequalities because the polynomial has a degree 2 and uses less than. So in this last example, if you notice, 2b plus 3 times b minus 2, if you are going to multiply this one by the use of FOIL method, you will arrive with a degree 2, and it uses less than or equal to. So therefore, this is an example of quadratic inequalities. So if you have questions, you may write it in the comment section. I will be happy to answer them. And guys, if you like our presentation, please do like, that would support my channel, and please do not forget to subscribe and to click that notification bell for you to be updated with my next tutorial. Thank you so much.